So now we're going to start the numericals. The numericals are word, and all you have to do is to just put the values. So it says that the compute the displacement field. The fields are given and compute associated strains at these points and compare the results by equation 2.2 and 2.3 with those obtained by equation 2.4. So all you have to do is to write the equation. So equation 2.4. So all you have to do is to differentiate. For example, you want to find out strain in the direction of x. So you differentiate with of equation u, and then whatever answer you get, you put the values as x equals 1, y equals 1, and z equals 1 in this, and you plug in these values in this dv upon dx, and you will get sigma xz. Similarly, you will do this for y, z, gamma x, y, z, gamma y, z, gamma z x. So after getting the results, you have to compare these results with equation 2.2 and 2.3. So that's how you will be able to solve these numericals. Move on. Transform the set of Cartesian coordinates. We are given the Cartesian strains in Cartesian coordinate system, and we have to move to this axis. Okay, all you have to do is plug in the values in the formulas that we have learned in the chapters, and then you will going to find out this value of strain which will be present if you transform this coordinate from x, y, z into x dash, y dash, and z dash. Okay. It says that determine whether the following strains are compatible. So you are given the strain fields. Okay. All you have to do is to verify that each of these equations are satisfied. In other words, you have to prove that left hand side is equal to right hand side. Okay. So if, alright, sorry. So if the left hand side is equal to right hand side, you can say that the strain fields are compatible. Now determine pi, gamma, u, and k for steel, brass, aluminum, plastic, and magnesium by using the followings by the values of E and V. So you have unknowns, mu and lambda. So you have these unknowns. All you have to do is to you have the value of mu and E. So you have two unknowns and two equations. So you would be able to find out these values. And once you find out the values, you place it in this equation to get the value of k. You have the strain Cartesian component this. Okay. Determine the principal strains at the point. Okay. And transform the new set. Alright. So there are two questions. The Cartesian components of stress in a steel is this, and the machine parts are this. Determine the principal strains. So alright, sorry. So in order to find out the principal strains, so the formula of principal strain is given. Wait a second. So this formula is given. Principal strain. Okay, and to find out the principal strains, you have to have. I think I missed the questions here. So there is a question that says that use the value of strain from question number 2.6. So I just forgot to paste this part of the question where it says that consider the values of strain from equation 2.6. So we have this question 2.6 and we have the values of strains. Okay. So what you have to do is that you are going to put the values here. Wait a second. Let me correct this first before I proceed. Alright, so I have just corrected this. So we have 2.27. Determine the stresses at a point with this data, and wait a second. We have to find out the stresses given this on the machine components if the Cartesian component of strains at points are listed in exercise 2.6. So 2.6 I have find out the value of strain, and with the help of this data I have to find out the stresses. So to go from strain to stresses we will going to use these formulas. So simply put in the values, you will going to find out the stresses. Okay. And now in 2.28 the Cartesian components of stresses at a point in steel are given as this, and you have to find out the principal strains. So in order to find out the principal strains we have to find out the strains first. So first we will find out the strains with this formula, plug in the values, and we will going to plug in here, and we will have E1, E2 and 3. Okay. Now moving on, it says the Cartesian component stress of a point of steel of the machine part. Okay, this is I guess the previous question, so I have already addressed it. And now the final question for aluminium, we are given E is equals to this and B is equals to this, and we have EX and EY, and we have to find EZZ. So the formula is this. Simply put in the values and you will going to get the result. Okay, so that's all for these numericals. Thank you so much.